To date, more than 500 planets have been observed around other stars, but these exoplanets do not necessarily resemble the planets in our own solar system. How did scientists discover this? Let's ask an astronomer.
Can you explain to us how these extrasolar planets were discovered?
Yes. So most planets are actually discovered by a method called a Doppler wobble. So that uses the fact that the star and the planet, they orbit around their common center of mass, and that is a point slightly offset from the center of the star. So that causes the star to wobble. So, for example, a planet like Jupiter, which is about 300 times the mass of the Earth, causes the Sun to wobble with a period of about 11 years, which is the orbital period of Jupiter, and a velocity of about 12 meters per second, so 45 kilometers an hour, the speed of a moving car. Now, due to the Doppler effect, the frequencies of the star shift whether the star moves towards us or away from us. And we can detect this shift.
That's fascinating. But how do we know that some of these extrasolar planets are so different from our own?
We find many planets that have an orbital period of about a year. So that puts them inside the distance from the Earth to the Sun. But the signals are so strong that they have to be caused by planets that are actually the size of Jupiter or even bigger. Now, putting such a massive planet so close to the star means that this is a very hot planet. In most cases, probably even evaporating. Now, in our own solar system, we only have Mercury and Venus, which are tiny rocky planets so close to the star. So having such a massive planet so close to the star is completely different from our own solar system, and it raises the question whether our own solar system is unique.
The diversity of other planetary systems observed is vast. In our own solar system, the 8 planets all revolve on almost circular orbits in the same plane, the ecliptic. But we know of exoplanets on very eccentric orbits. We even find planetary systems in which the planets do not all orbit in the same plane. The ESA and NASA missions Corot and Kepler have recently made great breakthroughs in detecting different kinds of planets. They have found rocky planets and even water worlds. These are planets composed largely of water that may be surrounded by atmospheres composed of hydrogen and helium.
So what do you think causes this great diversity of extrasolar planetary systems?
Well, we believe that planets form in what we call protoplanetary disks. This is a thin disk orbiting a forming star, and it's actually a remnant from the star formation process. And in this disk, the material starts gluing together and form planets. So you can imagine that if you have a different distribution of mass, or just a different amount of mass, or just other different initial conditions for this disk, that you can form very different systems in the end. So currently we're collecting a very large data set from space-based telescopes like Spitzer and Herschel, and from ground-based telescopes like the Very Large Telescope in Chile. And this will help us to link these first stages of planet formation to the planetary systems that we find.